Hello friends, in this video I'd like to solve the following problem from Baltic Way Mathematical Competition 2022, problem number 5. We wish to find all functions f from the set of real numbers into itself such that f of 0 plus 1 equals f of 1 and, crucially, f of x y minus x plus f of x plus f of y equals y times f of x plus 3. So the second part makes this problem interesting. It's a fun functional equation. Here are my hints. First, try setting x to be 0 and find f of y. Then take our very first functional equation, or rather second one, so take asterisk, and change x to f of x and use the previous result, and try to isolate the symmetric part of equation which you get. After that isolation, change x to y and y to x and compare both sides and set y to be 1 to find f of x. At some point you may also want to answer the question, can f of 1 be equal to 0? And finally, verify your result and remember about this additional constraint. So give this problem a try and I will see you in just a minute. Okay, so here is my solution. As I suggested, let's first set x to be 0. What do we get? Well, we have f of 0 plus f of y equals y times f of 0 plus 3, and that allows us to write that f of y equals y minus 1 f of 0 plus 3 for every real number y. Very well. We'll use it in a minute. Then, our second part, change x to f of x in our condition asterisk. What happens now? Let's take a look. So we have f of y times f of x minus f of x plus f of x plus f of y equals y times f of x plus 3. Okay, what can be done? Well, the first part, y times f of x minus f of x, it can be written as y minus 1 f of x. The second part will stay the same, f of x plus f of y. But the third part, we have f of x. We can use the derived equation written in yellow. So it's y times x minus 1. You know what? I will write it in yellow to highlight it. X minus 1, f of 0 plus 3. Plus 3. Okay. And maybe I will do one more thing. F of y minus 1 times f of x plus f of x plus f of y equals, well, what do we have on the right hand side? We have xy f of 0 plus 3 mine plus 3 times y minus f of 0 times y. I am not mistaken. I am not, very well. And now I wish to do the following. I will put this part on the left hand side and I will put this part on the right hand side. And what do we get? We get the following. f of y minus 1 times f of x. And what now? Plus f of 0 minus 3 times y. Okay, very well. Equals x, y, f of 0 plus 3 minus f of x plus f of y. Very well. And maybe I will put it in green ellipses. Very well. What now? Well, notice the curious fact. The right-hand side is completely symmetric with respect to x and y. Symmetric with respect to x and y. What do I mean by that? Well, if I change x and y, I have the exactly same expression. So the left-hand side must be symmetric as well. So I can change x and y on the left-hand side, and the result should stay the same. So that implies that f of y minus 1 times f of x plus f of 0 minus 3 times y equals f of x minus y, 1, f of y plus f of 0 minus 3 times x. Very well, and now this equation turns out to be very important for us. It's very important for us. Wow. It's so important that I will mark it, you know what, I will mark it 2 asterisk, for example. And now I wish to set something into my equation double asterisk, namely I will set y to be 1. So set y to be 1 in, well, double asterisk. What do we have? Now we have the following. Here we have f of 0. Here we have f of 0 minus 3. And here we have what exactly? F of x minus 1 times f of 1 plus f of 0 minus 3 times x. Let me compare it with my notes. Is everything all right? Probably it is. And now, let me take one more look, because I wish to be completely sure that I do not make any mistake. Yes. And now I will do the following. I will write it in the following way. F of x minus 1 times f of 1 equals 3 minus f of 0 times x plus 2 times f of 0 minus 3. Very well. And now let's notice something. Can f of 1 be 0? I claim that it can't. So maybe write it claim f of 1 is not 0 because proof if f of 1 equals 0, remember that this equation should be satisfied by all real numbers x. So then it should be the case that for every real number x, well, on the left hand side we have f of 0, so f of 0 equals f of 0 equals 3 minus f of 0 times x plus 2 times f of 0 minus 3. And that should be true for all x's. The only possibility that this linear function is constant, the only possibility is that f of 0 equals 3. But if f of 0 equals 3, then what do we have then? Then, if we go back to our very first initial condition, remember that f of 0 plus f of 1 should be equal f of 1. Let's maybe mark it, I don't know, triangle. F of 0 plus f plus 1 should be equal f of 1. Then f of 0 plus 1 equals 4, and f of 1 equals 0, which is contrary to our condition. Contrary to our condition triangle. So it cannot be. So that closes the proof of my claim. F of 1 cannot be 0, and that allows us to do something nice. So again, I will take, I will mark this condition triple asterisk, and I will change some things, namely change x to x plus 1, x over f of 1 plus 1 in our condition triple asterisk. Why? Let's notice what happens now. If I put, instead of x, I put x over f of 1 plus 1, so I have f of x over f of 1 plus 1 minus 1 times f of 1 equals, I can do it because f of 1 is not 0. It was the entire point of my claim. So that equals 3 minus f of 0, and instead of x, we have x over f of 1 plus 1 plus 2 times f of 0 minus 3. And let's notice that on the left-hand side, we are left with just f of x, and on the right-hand side, we have 3 minus f of 0 over f of 1 times x plus 3 minus f of 0 plus 2 times f of 0 minus 3. So it's plus f of 0. Yes, it is. And now we have an explicit formula for f. We see that f must be an affine function. So that implies that f is an affine function. Affine function. Yes, and that means i.e. f of x equals ax plus b for some constants a and b. The rest of my reasoning will be finding the exact values of a and b. Well, one connection between a and b can be found pretty easily, but first I need a new page. One constraint can be found by our condition triangle. Let's go back. Condition triangle says that f of 0 plus 1 equals f of 1. f of 0 plus 1 equals f of 1, and that means f of 0 is b, b plus 1 equals a plus b. So a equals 1. So now we know something. And now we will use our very first functional equation, asterisk. By asterisk, let's go back. By asterisk, this condition. So I will put everything. F of xy minus x plus f of x plus f of y equals y times f of x plus 3. And now let's put our function, which is x plus b. So we have xy minus x plus b plus x plus y plus b equals y times x plus b plus 3. And now let's simplify. We have xy minus x. Let's simplify what we can. Well, we can minus x plus x is gone. Here we have xy and here we have xy, so that's gone as well. We have so we are left with, on the left hand side we have y plus 3 times b, and on the right hand side we have by plus 3, and that can be only true for every y. Remember, that should hold for every y. That means that b equals 1. It's the only possibility. So our functional equation has only one solution. The only solution is function f of x equals x plus 1. It's the only solution of both of our conditions. Pretty nice problem, I'd say. That second condition was helpful. That, you know, that f of 0 plus 1 equals f of 1. It was very helpful at one crucial part at proving my claim that f of 1 cannot be 0. If f of 1 is not 0, then we can divide by f of 1 and the rest of my reasoning follows. So our condition green or teal triangle was in fact very useful. And yeah, so that's it. A very nice problem, very nice equation, I'd say. That's it. So thank you for watching, and I will see you next time. Goodbye.